dissects. Some people already know what they are. Some people don't. Go figure, I guess. Go Google it or something. So let's get started. So you know this is our Twitter handle. You know what to do. You take pictures. You include this Twitter handle, and then we retweet that, and hopefully you'll get 1 or 2 followers today. Can't promise anything. Maybe you'll get a bunch too. We also film and put all of our talks from ReactNYC to YouTube. So first of all, hi everyone who's watching us on the live stream. I don't know how many people are there. How many people are there?
There's the link to it.
The link is on what?
On the live stream.
On the live stream.
Yeah.
Okay. So hi everyone. Welcome to ReactNYC remotely. If you want to see all the talks from previous events, I think we have over 50 talks already there. All of them are really nice. Go to youtube.com/ReactNYC. Raise your hand if you're here for the first time. Great. Oh, welcome first of all. So for those of you who don't know what this is about, so ReactNYC is an event, is an event group where we have 2 events a month, about every 2 weeks. And every 2 weeks we have about 3 to 4 speakers, which means that we need a lot of speakers, right? So we want to invite everyone who has any experience with React or anything in ecosystem to share your problems at work, to share the libraries you're working on, any experiences or new ideas. Come talk to us, even if it's your first time, you're very shy, you know what to do. Come talk to Manon, she's our Director of Community Operations. She takes care of all the meetups. We'd like to have you on stage. As I said, we are doing events every 2 weeks. Every 2 weeks. So this is the proof. The next one is going to be on August 8th. The one after that is going to be August 22nd. Stay tuned for meetup.com/ReactNYC, and hopefully we'll see you there. A couple of announcements. Raise your hand if you are a technical lead, like CTO, VP engineering, technical lead, people. So that might be for you. For the rest, pass it to your tech leads. This is a new group called Vertex. It's a new kind of secret invite-only meetup. When we invite CTOs, VPs of engineering, directors of engineering to come and share their personal stories from their practice about specific topics. So we have the first event, the kickoff, on July 31st. It's going to be the first part of that is going to be about web performance. So we have really nice CTOs and principal engineers from big companies sharing their stories. Please come talk to Manon, she'll give you all the information about that. Another initiative we are working on is JS Pro. It's a new exclusive meetup for senior JavaScript engineers with at least 3 years of experience. We're gonna skip all the basic stuff and talk only about deep advanced topics. So also talk to Manon, she'll let you know how to get there. I want to say a big thank you to our sponsor for today, Woo. So Woo is like a passive recruitment platform, I think. When you go there and can passively look for jobs, they have a table right there in the corner, and they give away this kind of I don't know what it is. It's like things you put on your iPhone, then you can put cards. Yeah, credit cards. So it would be easier to steal your phone with all the credit cards. It's very cool, nevertheless. I want to say big thanks for Discovery to hosting us here, providing all the pizza. So big round of applause.
Hi everyone, my name is James O'Reilly. I'm the VP of Engineering here at Discovery. We're huge fans of React. We use React every day, and the applications we build for the companies that you see here on the sign. We do TV everywhere applications, direct-to-consumer applications, building with React.js, React Native. We're growing. We have a large engineering team here in Discovery. We do all of our own work, and we're growing. So there's a lot of engineers here spread throughout. I'd like to thank Andre for bringing the group here tonight. So look for me, look for one of the other engineers, talk to us about some of the open positions. We have like 7 open React positions. Yes, there are any raise of hands of any engineers here looking for React work? come say hi during the intermission. I'd love to hear from you. And really excited about this event, and thank you.
Thank you so much. And honestly, we should say a big thank you to all the attendees today, so give yourself a big round of applause. Which is great. You are the reason we are doing these meetups, so please keep coming, keep sharing the word. We already have about 4,700 people in the meetup group, which is great. So thanks for coming, and without further ado, let's begin the show. Ready? And get the Wi-Fi first.
We're going to start off with a super fun topic involving a lot of statistics, so I apologize. So I'm going to present today about A/B component testing in the land of the virtual DOM. My name is James Villarrubia. I'm currently the CTO of a company called Work. It is focused on delivering kind of corporate insights based on employee flexibility, kind of how you make flexibility work in the environment. I have a bit of a side hustle with my friend Bernie called Mount Cleverest. It's a free online textbook with AI. I've been VP of product for a cybersecurity company, a couple patents there, teach at UVA, DNC front-end developer. I was not the cause of the hack. And before that, I was a statistician for the Pentagon Lighthouse. So I've been around for a lot of different things in public and private sector, and everybody struggles with optimization and A/B testing. It is universally hard to do. So one quick story to kind of set the table. A few years ago, I was in Hong Kong for a business trip at an Airbnb, jet lagged out of my mind, a little tipsy, because what else are you going to do at 3 a.m.? I get an email from my boss like, hey, we'd really like this demo. So I was like, okay, well, I've never built an iOS app before. I'll figure it out. I'd heard of React Native. I said, let me give it a try. And like 10 hours later, I stood up a nice little React Native demo app that kind of like showed off our protocol and all this cool stuff. I bring that up because that code base that I sort of drunkenly made several years ago is the basis of a core offering of a major company right now. And that's terrifying. But it also speaks to kind of the value of React in that it is really easy to build something and roll it out and launch it. It is very easy as like a basic developer to get something stood up, a solid MVP. The problem is that you can go from MVP to alpha to beta to like launched product with that same code base very quickly. And if you have a CEO who's like banging on your door, it's probably going to happen that way. So that means things like A/B testing that require kind of architecture thinking, you have to build in early. It is not something you can actually wait to do on your beta product, because by that point your architecture is already built and you're going to have to recode a lot of stuff. So why is A/B testing in and of itself important? And for those that don't know anything about A/B testing, I'm going to just breeze through a quick refresher. So you've got two buttons. This is a classic issue. This is one from politics that I know of personally. So we had one button. It was submit. It was red. We tweaked it. We said, hey, let's make it green and change the word donate. That one change increased our donations by $100,000 a month. That is an absurd amount of difference for a color and a word. But those are the things you can kind of discover. So here's a quick one for you guys. Raise your hand if you think the subject line from A is better than the subject line from B. So all in favor of A. A couple hands are there. All in favor of B? Okay. So mostly the same subject line. B has a 100% increase on click-throughs. I don't know why. People are weird. But like, you got to discover this stuff. And part of the hard part of A/B testing is it is sometimes unintuitive, the things you discover. If you had gone the other way, if you'd started with B and then changed to A because, oh, it's got an exclamation point, it must be better, you would be, have a massive drop in your click-throughs. So what is A/B testing? Quick refresher on the stats. So it is, on the continuous data side, it's actually based off of something from 1908. It's the student's T statistic. The student is not a student. It's a pseudonym by this guy, William Gossett, who's a biochemist at Guinness. So A/B testing was originally used to sample what version of their beer that they were brewing was better, which I think is pretty cool. The big important thing is it is not a normal distribution. It's fatter and shorter, and I'll talk about why in a second. It's mostly about comparing mean versus mean, and evanmiller.org is a great set of tools that will essentially do all the math for you. You just got to sort of understand what you're looking for. And then the other kind of piece of A/B testing you guys might see is discrete data, so that kind of click-through rate, which is usually the n-1 Pearson's chi-square. You don't need to understand much in that. It's just know that it's successes out of opportunities. And that's exactly the one we're going to talk about today. So why not the normal distribution? Why is it not that thing you learned about in high school and college? Because the variance is unknown. When you're building new components, you don't actually know that the variances is going to be beforehand. So the student's t-statistic is essentially a sort of flattened normal distribution because it is a risk-averse approach. And also, it works really well for small sample sizes. So you might think, oh, I've got 10,000 users on my site. That's really cool. But the actual people that are going to hit one specific test and variation might actually be really small. So 6% click-through on one form. Then you go to, OK, of the people who see the form, who actually completes it? So the numbers actually go down pretty quick in web traffic. So that's why, again, the t-statistic is much better than the z-test and normal distribution. And here's the quick math that you can look up later online if you're really interested, but I'm not going to go into it. So there are a lot of tools in A/B testing. There have been tools for a long time. Google started this with kind of their 41 flavors of blue. Their first A/B testing was actually a total failure. They screwed up the code. But it was developed with largely a static DOM. So it was a jQuery-like library dropped in your header, and it manipulated your page on load. So you've got that red button in your code base, and boom, it'll swap it to green on page load. So Optimizely was really good at this. They were using the Obama 08 and 2012 campaigns, and they had big ties to Google. VWO is really good, convert.com, things you've heard of. So the problem is React rebuilds the DOM over and over and over again, right? It is breaking and erasing all of those nice manipulations you built in Optimizely. So kind of big womp womp there. So I'm going to talk about kind of 3 paths to fix this, to kind of get over this gap that these kind of jQuery-ish libraries have left. So first, the app lifecycle. So we all should be familiar with the React app lifecycle. This is a quick and dirty way to do this, right? So you've got your app component at the top. You've got it did mount, component did update, and every time it does that, it calls those functions. You just go to your window object, you pull out, I'm going to use Optimizely an example here, Optimizely.hook. Optimizely runs its little JavaScript code, and boom, you've made your manipulations. The problem with this, so here's what the code in Optimizely would end up looking like. CSS selector is really basic stuff. The problem with this is, the DOM manipulation is still outside the virtual DOM, so it's going to be slower. It's like I built this great app, and I got all the benefit of the virtual DOM with React, and I'm throwing sand in it, literally with every render. So not a great idea. It's also disconnected from the client-side component logic. So the logic of Optimizely in your experiments is totally separate from your actual application. And it really is only going to work on kind of small changes. Oh, I'm going to change that button. But if I want to swap out an entire component, this breaks down really quickly. But the pros are you get to use Optimizely, so your marketing team really likes you, and it's very quick and dirty. Second approach. So we're going to bring kind of the Optimizely-ish library into a component. React is component-based, so this makes sense. So we're going to essentially do the variation manipulation at that higher order component. So that really some pseudocode here. You got the app, the header, the experiment. And then in that, you've got a couple variations. So that experiment higher order component is going to decide which variation to show, right? Very simple kind of swap React logic. So this is some sample code. Again, all the code is on GitHub, and you can find it in the end of the links at the end of the slide. Feel free to use it. So this is very simple code, but you can see that in the get variation function, it is pulling out the Optimizely data object. So when Optimizely pulls its code down on that page load, it pulls down essentially a big object about telling you what all the experiments are. So this is, hey, does this experiment apply to this component? Oh, it does. OK, does this particular variation apply to this component? Yes, it does. Great, show it. So pretty simple logic, but you're in the component now. So then, of course, what you end up seeing is kind of your variation IDs, which are tying to your Optimizely logic, and one kind of wrapper higher order component. And of course, credit to sheshbabu.com.
So pros of this, you still get to use the optimized interface. Your marketing team loves you. You're using the full component structure, yay. And you're inside the virtual DOM. Great, you've crossed that big threshold. You're sort of using React correctly with A/B testing. The cons, you are splitting up your state management. So now you've got Optimizely sort of doing some logic about it knows what it's supposed to be happening, and your app doesn't really. You're still disconnected from component event logic. So your components are actually passively receiving information from Optimizely about what the experiments are. It really can't control it, right? So that one-way flow in but no way out leaves a lot of room for issues, and it kind of cuts you off the knees when you want to do things more complex. So the win events, so you think about the successes out of opportunities that we talked about earlier, the win events have to be collected in some other way. And of course, this does not play well with Redux, which is, I think, kind of becoming a pretty big standard. So the third option, and this is the option that we use at work.co and with Mount Cleverest. It's a hodgepodge of a couple libraries that I saw out there that none of them quite could do this, but we brought this together, and credit to the team over at Work for helping with this. Here's the basic life cycle of Redux, right? UI triggers an action, dispatches out to the reducer. Reducer makes an immutable state change, goes to the store updates state, trickles all the way through. So if you are going to be tracking a lot of behavioral data about what's going on in your app, Redux is a great way to do it, because all of those actions, everything your user does is essentially probably going to be an action, dispatched in some fashion. There's a great tool called segment.com. If you're not, it used to be segment.io. Segment.com, I love it. It's a great tool. It is like the behavioral event warehouse. You just throw all your platforms into it, just points to the same warehouse. It cleans it up and then pushes all that data back out to all the various consumers that you might need, whether that's a BI tool or whatever. Segment.com. So what I found was that Segment actually has a nice little plugin for Redux, which will act as a middleware, capture the events that are coming out of the reducer, say, hey, is this an event that looks like a Segment qualified event, something that Segment cares about, a behavioral event that someone in the BI tool, whatever, is interested in. If it is, great, send it to segment.com, just dump it out there. And then it kind of gets out of the way very quickly from the Redux state loop. So this is actually a really cool idea, and I thought this is pretty valuable. How can I use this? Also, how can I get my A/B testing data, all of my experimental data, what people are doing with one variation or the other, into that same flow? Because if I have a BI tool, I don't want to have to go to Optimizely to look up one thing and then my BI tool to look up everything else. So this is a way to get your event data and your behavioral event data and your experimentation data kind of in the same flow to the same resource. And this same structure can be used without segment.com. You can pump this data anywhere you want, but that's what we use. So what's this going to look like? So you have that original event object or action, kind of standard. You got your type, and then whatever data you're going to pass along. So with a segment event, it's a very, very slight modification to your event or your action inside your Redux code. All you're really adding is that meta object with your analytics and some segment-specific stuff. But that's all it is. You're just appending that meta thing and saying, hey, this is the stuff that I care about and I want to track in segment. And it handles the rest. It is pretty slick. So when you log into Segment, you see some cool stuff like this. So it's tracking all of these events, the time codes. It tells you what happened in the kind of pretty format. So Segment does a pretty good job at handling all this stuff. And of course, you can pump it all into Redshift or Postgres and kind of handle that way too. So let's talk about the actual middleware. How are we going to make the Segment middleware work to our advantage for A/B testing? So I said, great, I'm going to just make my own middleware and just shove it right ahead of the Segment middleware. So I know that every time I do an event, every time I do an experiment, I'm going to have essentially two actions that I care about. That a user is playing the experiment. Oh, great, like I'm seeing the registration form. And then whether they win. So I'm playing version A of the registration form, or I'm playing version B of the registration form. And then when I click register and I complete, that triggers a win. So great, that user got through the win. So there's a success and an opportunity, right? Goes straight back to the math. So I built a really lightweight middleware, and all this is doing is it's looking out for any actions of type play and type win. It takes in some data from the component or from that was called with the dispatch, converts it to a segment-friendly friendly object, and then pushes it right into the segment middleware, which then pushes it to segment, and the Redux loop continues on. So very kind of, computationally pretty simple stuff. This should look familiar. This is a lot like path 2 that I talked about earlier. So this is, and again, a higher order experiment component with some variations inside. So what this is doing is saying, great, I've got an experiment named registration form variation. I've got 2 variations, one that has some extra text, one that doesn't, and then the component inside of that. This is exactly what we were doing before. I'm just rebuilding it for this Redux version. So what does the function look like? What is that win function? So in the higher order component, I'm actually going to pass the kind of on register event, that click. I want it to actually be managed at that higher order level so that both versions, both variations are calling the same core function. So all that does is say, great, tell me what experiment and what variation got passed down. Tell me where I'm at. Send that data along the segment. That's it. Click the button, send the data. So this is, again, let's say you want to, you got to, of course, get your experiment structure in. And this is where the kind of the downside of this one approach is that I have to manage my experimentation inside the code base. You could swap out your code base and say, I'm going to use that optimizely data object. But if you notice this section right here, variance, I'm essentially doing the same thing that the optimizely data object is doing, describing my experiments. I'm just doing this when I initialize state at the very beginning of the React app. And then I throw it in, again, when I create the store as some middleware. So this is my experiment middleware. It's the thing that's doing everything else that we just talked about. So pros of this approach. It's optional use of optimizely interface. It's using, again, the full component structure. It's inside the virtual DOM, which is what we wanted. It's utilizing Redux state and store, which is really good, because I think a lot of people are using Redux these days. And the win losses are contained inside the functional flow, which is a big difference. This means you can call a win or a play event from anywhere in your app in the same structure and see that data pumped into your BI tool. The cons. It is a little bit more complicated to build, but not impossible. It must be adapted to your own stack. And of course, it requires code deployment for new experiments. So now what? Let's say you've built this thing, and again, all that code is available on GitHub. Feel free to use it. So future improvements. This kind of gets blown out of the water when you start talking about server-side rendering or static rendering logic. It's not impossible, though. You're still going to get like that flash of whatever version the server decides. If that's not the one that is cookied in the user because they've already been to the site, then you're going to see a flash of the wrong module. Static render, you're going to see a flash of no object, and then suddenly the object as it has to kind of wait. So the initial render is going to miss the benefit of that static render. Still haven't quite figured that out. If you've got some great ideas, I'd love some help. We've actually been experimenting with moving the experimentation and deciding what the experiment should be in CloudFront at the Lambda edge. So running a tiny little serverless function every time we refresh the cache that decides like, hey, this user with this cookie should get this version of the experiment. And that way it's getting passed down as part of the initial payload. And that means you can kind of skip around all the server-side and static rendering stuff. So gotchas. The novelty effect. So when you're looking at your end result data, don't assume that the variance that you're going to see at the end is actually going to be stable. So heteroscedasticity is the fancy word for this. Users are probably going to settle into experience. So they might be like, ooh, the interface looks really cool or new. I'm going to click that button. So those tiny changes of just showing a new thing can get users excited. And you really need to, anytime you have that kind of new experience with old users, you definitely want to make sure you drag out your experiment a little bit longer. Statistical significance. This is the big mistake that everyone seems to make, is that as soon as you cross that statistical significance threshold, you type in your numbers on that little web form, you're like, oh great, we're statistically significant. You stop. That's a terrible idea, because that statistical significance is just another measure, and it will bounce up and down over a while. Eventually, it will converge to something. But this is where sample size, deciding the correct sample size is very important, and you should stick with it. And don't even tell your CEO that you've got some kind of data, because if you do, and you give him or her like the opportunity to make a judgment on what is essentially incomplete data, they will. They will always move faster. So this is just avoid it, right? Say, oh, we got to wait to 3,000 users. So how do you know that it's 3,000 users? So minimum sample size is the other kind of big gotcha. Real changes are hard to detect in web development. Again, Evan Miller has a great sample size calculator. But think of the distinction, the subtle difference here is like a 10% conversion rate on a page with a 2% detection. So I'm detecting anything outside of 8 and 12. I need 3,000 users, roughly 3,200 per event. For 8% conversion on a page and a 1% detection, so I'm going from 7 to 9, that is a 10,000 users per variation. That is a 3x difference in the number of experiments you run. So this could drastically change the kind of like tolerance that you're looking at for like, does my experiment actually make a difference? And again, this is not math that is super complicated. You just need to know what to plug in. So again, Evan Miller really helps with that. So this is what the tool on Evan Miller looks like. Baseline conversion rate, minimum detectable effect, and it just tells you sample size. So again, these are all the credits for the team that help with all this stuff. All the various packages and things I drew from and have looked at over the last year, kind of building this stuff out, is all there. So any questions?
I have time for 2 questions.
Not as much code related, but regarding sample size.
Mm-hmm.
Imagine you're launching your MVP and you don't have that many users on your website. Is it still worthwhile to run A/B testing if you can build that requirement?
Yeah, so the question was, is it worthwhile to run A/B testing if you don't have a huge sample size? No. So what I say, like, A/B testing is for optimization, but I brought up that story in the beginning about kind of Hong Kong because you want to build this into your structure early so that when you do need it, it's there. And you can build experimentations early on, and like it will slowly cross that threshold. But yeah, it's going to take a little bit longer to reach the threshold of sample size. But so don't expect to get results in a week. But you might get results in a month or 2, which could be very indicative if you've got an MVP that you're working on for a while.
So like the problem with, can you run multiple experiments at the same time? Because like the problem is sometimes you might not be able to attribute which experiments are impacting your final variable.
Yeah, so the question is, can you run multiple experiments at the time and determine which is impact the variable? It depends on how you structure the app. So again, this is the value of connecting the win event inside your application logic, is you can say, hey, when I randomize my experimentation in my initialization state in the Redux store, when I initialize it, I can say, you either get all of these or all of these, or you can get this one and this one and this one in sequence, or this one and this one and this one in sequence. So there's a lot of variation from a data management standpoint. As long as you are collecting the various events and you've got the win events, you should be able to create a profile of everything the user has ever done and draw simply a multivariate model against that later if you really want to say, oh, is there some cross-pollination? But usually you're going to have an event like, I loaded the registration page and I saw the registration got clicked on version A, not B. So it is usually pretty tightly coupled just in the structure of the code itself.
Thank you so much.
Right.
Hi. I already love this because I love A/B testing, which I don't really get to talk about at home, but this seems like a cool place to say that. So, I'm Kurt. I'm talking about Lighthouse, and I'll tell you what Lighthouse is in a minute. I think the better title for this talk is React giveth and JavaScript taketh away. So that's what we're going to talk about. Lighthouse is a tool for measuring speed of applications. I've been shocked to find out, since I started working on this, that some people don't care. It's a very strange thing. So I've learned to start pitching people on why speed matters. And the reality is speed matters because you make more money and you get more users, and also for pride reasons. So I have this huge page of speed propaganda, if you don't believe me, that I'd love to talk about later. But right now, hopefully you all think speed matters, because that's what we're talking about for 22 minutes. like I said, or he said, my name's Kurt. I have worked at several companies. I helped build Ars Technica. I even wrote a terrible review of Mozilla back in like 2000 for Ars Technica, which is very cool. They got bought by Condé Nast. They're over in the Freedom Tower now, right? Built a company called Compose. We did hosted databases, which we sold to IBM, and their building is over there. There's buildings all over for places I don't work anymore. And then I'm now building a company called Fly, and Fly is a global application runtime. And the idea is that you build your apps, you deploy them to the edge, so you're not having to use like Lambda at edge. You just write your app and it runs everywhere, and you don't have to make CDN choices anymore. But the primary reason Fly exists is for speed purposes. And you will probably discover a little bit of my agony along the way. I have some slightly angsty slides you get to enjoy. So, boy, I didn't take that transition out. Okay, Lighthouse is a tool Google created that it assigns a score of 0 to 100 that's supposed to sort of match the human perceived performance of an application, specifically an application that you're loading for the first time. So there's this sort of spectrum of applications that Lighthouse is really good for, where you can think of them as like publishing companies where they have kind of similar content they show to lots and lots of people, and then all the way down to the scale of Facebook, where everyone who logs in sees entirely different stuff. Lighthouse is really, I think it's useful for the entire spectrum. It's really useful for these types of sites where like the first impression happens a lot, and you will lose people immediately if performance doesn't work. If Facebook is slow to load, you're probably still going back tomorrow. If Levi's.com is slow to load, you're probably not buying jeans from them that day. It's kind of that distinction. But it's a very, very neat tool because all the businessy folks at companies that don't understand what time to first byte mean can wrap their head around a Lighthouse score and how important it is to users. React is really good at Lighthouse by default. And a lot of this, and we'll get into this a little bit later, is because it's modern, and browsers are modern, and React has components, and it loads things in a way that Lighthouse likes. And a lot of what Lighthouse scores come down to how you actually load your resources. So this talk is a lot about Lighthouse, React applied, and then some other bits that it's useful to really understand what's happening with or without React in the JavaScript app loading world, with kind of React layered on top. Discovery.com is a modern React app. I have two caveats to the rest of the presentation. One, if you worked on this app, I apologize. Two, hold tight, it gets better. So, Discovery.com is on the spectrum of publishing company. They get millions of users a day see this site. They care about some things, and it just depends on which page what they care about. But it's not a Facebook level React app. This is sort of a publisher level React app. So arguably Lighthouse is incredibly important. So I ran Lighthouse on Discovery.com, and there's a few very important components of a Lighthouse score. The first is what is the first meaningful paint, first contentful paint, which is the first time anything really shows for a user. The second is first meaningful paint, which is kind of like the hero sort of above the fold bit of the app is actually kind of complete. In this case, for Discovery, it happens when the shark loads. And then the last is time to interactive, which is can the user actually interact with this app? You'll notice that Discovery.com scores a 5 in Lighthouse. And as I said, the score is 0 to 100. The 5 is like lower 5%. And a lot of that is derived from these three numbers. So in general, you want to shoot for a first contentful paint of under 2 seconds. You want the gap between that and the first meaningful paint to be as small as possible. And then time to interactive needs to be something like a human will wait for, which is typically about 7 seconds. So this page is painful for users that don't block ads. The reason the score is so low is because Discovery.com, like every publishing company, runs a lot of third-party JavaScript to do things like A/B testing and analytics and ads. It's always ads, right? And this just murders the score. So the very first thing my low-res angry balloon here did was let's just run it with Ghostery, which will block a lot of the third-party stuff because it's privacy, right? Ads are not helpful for privacy purposes. And you'll notice that the metrics are all a lot better. Specifically, time to interactive, it's half. So my little clock there basically started 11 seconds counted down, and then we have a fully functional page at this point. Another little sort of asterisk here. This is sort of a simulated page load. This isn't, Lighthouse by default will actually show you the mobile view, but I wanted to show you roughly what you'd be seeing if you were on like a widescreen display. So just by turning off everything that makes Discovery money, we've made the page twice as fast. And we've upped the score from 5 to 36, right? And this is This is agonizing. If you built this app, this sucks. Like this has been going on for 20 years. Like there's been this tension between what I let other companies inflict on my application and what my application actually does. And it's getting better. The world has to change, but it's still an impossible battle. So by default, we're just going to ignore all third-party scripts because nobody in here can affect that right now. Nobody has like the political cachet to say shut off all the ads until they conform to our speed standards. It'll happen. It's just going to take a while. All right, so now that we've gotten Discovery's not making any money, but it's a little bit faster, we can actually go hog wild and make it as fast as we want. Lighthouse has a really useful tool for explaining what you need to do to get a better score. Number one, serve images in next-gen formats is not React specific at all, but like 98% of the sites on the internet have this problem. You don't, like browsers can do much better things than JPEG and PNGs at this point. So like most everything WebKit based can do WebP, which tends to be 40 to 60% smaller for visually exact images. Mobile iOS can do JPEG 2000, which nobody's written an encoder for, so you can make it work, it's just nobody really bothers. And these are ways with two really popular and one my company to turn this on for your application. And this is the only time I'll be really promoting what we're doing here. But if you're using a CDN that's not CloudFront, because Amazon CDN is very basic, you can just turn on WebP for any browser that can detect it. If you're writing an Edge app with us, you can just turn on WebP for any browser to detect it. So it gets our score up. We went from a 30-ish to a 46 at this point. And what you'll notice is that the first contentful paint came a lot faster. We're down under 3 seconds, which Lighthouse likes. First meaningful paint's actually a little slower. And then time to interactive slowed back down. So that was really confusing, right? Oh, man. All right. That one wasn't animated, but you've all got the gist of the loading images at this point. Whoa. So this one's, I'm failing my transitions. So what ended up happening when I ran this Lighthouse thing is it said defer off-screen images came up, which is a happy accident if you've ever met Bob Ross or watched his painting show. Because I wanted to talk about lazy image loading. Man, I didn't get to see Bob Ross very long. We're going to wait another couple seconds and see him pop down here. Bob Ross. Loading images is surprisingly complex. That image tag is not very powerful. So the HTML5 has introduced things like source set and picture boxes. And what these are is ways to give the browser the image size it actually wants, which is not exactly loading images when they need them, but this is something the Discovery folks did really well. When you load up if you load up their app in a browser or on a mobile device, it'll actually give you the size image you want using this picture selector right here. And if you look in there, you can see the widths that their image API is generating for each one. What's interesting is this is what we want right away. This is the thing that matters the most at the first page view. And then this one we want later. This is the thing that you don't actually want to give people until they need it because it's not visible and it affects the Lighthouse. I'm saying it affects the Lighthouse score. What it really means is it's making everything slower. So what happened with my test is we failed at that. We broke the lazy loading that was happening on Discovery and it made everything actually slower despite having a slightly higher Lighthouse score. So humans shouldn't write that HTML. They shouldn't actually write image markup for anyone, which is why we have things like React to help us write image components. This is an image component we've implemented for cars.com, and this is actually rendered server-side. And what this does, and this is why we call Slido code, so it doesn't actually work, it just looks like it's on a slide. But what it basically does is it takes an image URL, it takes a list of sizes you want, widths. It takes a list of widths you want. It generates that HTML for you, but then this one gets a little cleverer. And what it does, and you'll see that up there, the LQIP is shorthand for low quality image placeholder. And what this does is it gives you back a very small, very blurry, not great version of an image that you can inline in the app itself so it loads instantly, and then you can bring the full powered, like high fidelity version back. And the effect that has on performance is we're down to 11 seconds, so you only have to sit through 2 more of these. Right, so our numbers are improving again. We're back to time to interactive, so we've sort of unblocked how long it takes to get that menu to function by making images load the way the Discovery people already did. One interesting thing about lazy loading is it's great for Lighthouse scores, but it's also pretty good for the user experience. This is what you see when you first load the page. Depending on your connection speed, it'll sit here for 2 or 3 seconds, and then you'll see this happen. It's not the best, humans are like, that's jarring, right? We went from solid black to this very neat shark illustration. The lazy loading lets you have a blurry Rhonda. So this is a 4K embedded image of Ronda Rousey. And what we did was we took the big master image, we shrunk it down to 120 pixels wide, and then we blew it back up with the HTML. And it's now inlined in the page, so it loads instantly. And then what happens when they get there is it just suddenly fades into very high fidelity. It looks really, it's actually a really neat effect. There's other techniques you can use for that. So the image component we use and the image components you should probably all be using in your apps take care of that for you in conjunction with either a CDN or an Edge application runtime that'll let you do the blurry images. So what else can we improve? Now that we've unblocked our images, we get on to, all right, these are things that have to load before we can render the rest of our page. And this is again, Google's cheat sheets are really great for this. So we have things loading that the Lighthouse doesn't think we need. And Lighthouse is very specific about this. It will know that like you don't need that first CSS file until the page is been scrolled, for example. So basically you can just follow these sort of dumbly and make it work really well. Loading assets is really easy in the React world because we have HTTP2. Like you don't do things, you don't bundle one big JavaScript file anymore. That's like, at this point it's 6 years old, which is like decades in the internet world, right? You do what React does, which is you take each component, you break it up, you let the browser be smart about caching and loading the ones it needs. You use async or defer module in your script tags. You kind of bundle the CSS to match the modules you need, and you can do some very intelligent loading. It's very, very nice in React world. React loves HTTP2, it loves defer. And so this is, again, this is a Slido code again. I just chopped down what's in the Discovery app to show you exactly the components it has down there. What defer does, if you're not familiar, and it's worth sort of understanding this, defer says, I've seen you, like I recognize that you're here, and I will get back to you after I place you on hold for a little bit. So it sees the URLs for the scripts, it keeps track of them, it knows that after it's done rendering and executing any script that's not deferred, it can get back to these. So it's great for like, I have my embedded blurry Rhonda and all my HTML, and I want to take care of that first, and then I want to get these scripts later to sort of enhance the experience. What's interesting about this particular thing is these are 3 third-party libraries that are blocking rendering again, right? Remember that angsty slide earlier about how bad third-party JavaScript is. Those are, again, 3 things that have nothing to do with the Discovery app that are holding up my experience watching it. What's interesting is I don't have this, like anyone who runs an ad blocker gets a great experience. Anyone who Discovery makes money off of gets a terrible experience. It's very unfortunate. So loading assets isn't really as simple as it should be because you have to contend with other people's code. And the people who write third-party JavaScript are not great JavaScript developers usually. It's usually the cheapest people an ad tech company can hire, and you're lucky if they don't use document.write, which will just replace your whole app with a blank page. All right, so we ripped out more third-party assets, right? So we're down to almost 2 seconds for the first paint. We're at 2 seconds for the first meaningful paint, because what we've managed to do is we've managed to unblock the browser, and it's able to grab the image while it's still rendering the layout, and it does those things almost at the same time. Time to interactive is now under 10 seconds, which is actually getting pretty good. Lighthouse simulates a mobile device, and the reason for this is mobile devices aren't really getting faster, they're getting stagnant. The mobile devices you buy now are cheaper than they were 2 years ago, but they're basically the same speed. So Lighthouse is an interesting look into, like we're probably all using modern iPhones and nice laptops and things. Lighthouse is a relatively good way to simulate what most people are seeing. And so under 10 seconds is actually pretty good, sadly. So this is sort of a truncated talk, and I think you could, most of these, like you could do an entire talk on image loading, you could do an entire talk on how to actually use modules in your React code and what to give browsers. You could do an entire talk on third-party JavaScript if you wanted to do that. And so these are like, we did basically 3 things to go from a 30-ish, like I don't really think going from 5 to 30 counts. Like we went from a 30-something Lighthouse score to about a 69. You really want to get to 90 plus, and what 90 plus sort of suggests is you're in the top 5% of the best performing apps on the internet, which there's a lot of apps on the internet. It's a nice way to differentiate yourself. If you care about SEO, it's a nice way to get better SEO. So what you'd actually do to take the rest of this page to 90 is you'd inline the CSS you needed for that hero image. If you noticed, one of the blocking assets was actually a little CSS module for that particular component. You'd go look at what Gatsby does. If you haven't messed with Gatsby, Gatsby is a React-based static site generator. and it's actually very fascinating. What it does is it renders a complete self-contained HTML document for each article or thing it's doing that loads incredibly fast, like 90 to 100 on most sites unless you've done something silly. And then what it does is it wires up React, so when you click on a link, you're not loading the bloated page again, you're actually just, you're triggering a React event and everything's happening very fast. It's really astonishing to go to most sites and then go to a Gatsby-based app and then click a link and it basically repaints the whole document before you've even seen anything happen, even if you're just clicking on like About Us and looking at people's headshots on a company. And then get rid of the third-party JavaScript, which I couldn't even write again. Oh, right, one more thing. The Discovery app has 300K of React state in the HTML, which is huge and slows things down. In fact, it's all redundant data. So all of these things are also HTML elements. And I was kind of surprised to see that. And so what's interesting is it gzips down pretty well since it's redundant data. So like all those URLs that happen twice, it's really easy for gzip to do its thing. But un-gzip size of assets is a reasonable proxy for how long it takes a browser to kind of parse and take it apart. And so they're using something called React Transmit Packet. It's a library I haven't used, but it's a state management plus, I think, if I read the GitHub repository correctly. If you could actually get rid of this, it would have even improved our score a little bit more. All right, so that was a whirlwind tour of Lighthouse with a little bit of React dabbled in there. If you care about this stuff, you should definitely go look at Google's docs on Lighthouse. They're really good. You should look at Gatsby.js. You should actually use it to generate a site. It's very interesting. You need to look at script defer. And what's fascinating about a lot of these types of things is they're new and they're really well supported if you care about everything except IE11, which is very old at this point. But there's also ways to use defer and fall back to an IE11 compatible thing. And then this is a really interesting JavaScript library. It's not React specific, but you could wire up to React pretty easily that takes, and it manages lazy loading of everything. And so you can make it act on if you've not used the image observable API in a browser yet, what it does is it lets you trigger an event when the element you care about gets close to being in view. And so lazy sizes is just a nice way to not have to rewrite all that JavaScript. And then also, I actually really like getting criticized nicely. So you should, if you have ideas or if there's things I didn't cover or if you didn't think something was quite like relevant for what you're here to see, I'd love to hear about it. And so feel free to email me or at me on Twitter and then talk to me after. But otherwise, thank you very much. And I probably have time for one or two questions. Two questions. Oh, so you can.
Do you know if any alternatives to Gatsby maybe require less configurations?
That's a good question.
Do I know alternatives to Gatsby that
You would recommend.
that require? Do I know of any alternatives to Gatsby that require less configuration? It depends what you're looking for. If you want just a static site generator, like Hugo is awesome, but it's written in Go and has nothing to do with React. If you want to see like how React would work if you had a static site to generate, Gatsby is the only thing I know of that does that very well. I think one of the big problems Gatsby has, particularly at the companies that are customers and like Discovery, is that it's really easy to make a nice isolated Gatsby site. It's really difficult to make the rest of your application behave the way Gatsby does. And I'm hoping they improve that because they just raised a whole crap ton of money, so we'll see.
Another one?
What do you think about server rendering? Do you think server rendering and hydrating your app makes more sense performance-wise, or just spitting out the JavaScript and proxy?
All right, so the question is, do I think server rendering and then hydrating the app makes more sense performance-wise, or just spit out the app and let the browser do the thing? I'm actually a tremendous fan of server rendering, and one of my dirty secrets is most of my React work is not on the client side at all. It's a lot more, if you've seen how Netflix does their app, what they actually do is they render the markup, they ship it to you, they ship a tiny JavaScript shim that makes everything work, and then they load the rest of React later down the road, which is a lot closer to the type of work I've done. Server rendering is insanely important if you care about SEO. Google will actually spider and run your JavaScript. But we've tracked how long that takes. It takes 2 days. So basically, they'll crawl the page. 48 hours later, you'll get a weird, like really late page load event. It's very interesting. It screws up all kinds of browser tracking that we've tried to do. So it takes them a while. And then the other thing is like server rendering is really the fastest way to get to that first, what Lighthouse cares about. which again matters for SEO, but I think it's just like if you're doing apps that you don't download from the App Store and are web loaded, it's just the best way to get that good first experience is to. Now, I also griped about how big a state was in the HTML, so like it's not an easy problem, but I would definitely server render.
Go back and get that state later asynchronously to keep the first byte.
Yeah, exactly. And I would try, and I think this is one of the things like Redux in particular is meant for Facebook style applications and not necessarily for discovery style applications. Depending on what I was doing, I look at Preact, which can rehydrate without doing this. It can actually discover that from the nodes. Or just, make it do like Netflix and maybe not hydrate with React exactly, but bring it in later and have like later HTTP requests do all that work.
Thank you so much.
Cool. Thank you. Thank you.
All right, so what's the plan? So we're going to have something cool right now. Should I tell them to plug their phones? So I'll tell you. We're going to have 2 talks. We're going to have something cool, then we're going to take a break. Again, we're going to have 2 more really awesome talks worth staying. So yeah, that's it.
HyHNuVaZJ quiz. Who's familiar with this? No one? So, take out your phones.
Don't get on the Wi-Fi.
Yeah. Who's using iPhone? Raise your iPhone. Who's using Android? Who cares? That's the way it's going to be. Let's just fix the resolution right here. We're going to classic mode. Yep. All right. So go to Kahoot and type this. Please, you can use your real name, you can use a fake name. We don't care. Are you able to? It's waiting for class. All right. So you can use your real name. You can use a fake name. We actually don't care because currently everyone is getting connected. We're just sucking all of your private information out of the servers. We've got no privacy policy at all. Where's the music?
I don't know. Is it muted?
Broadcom?
Internal speakers.
Yeah. Yeah? I can tell you something about this piece of music. No, not everyone knows this, but this is actually a piece by Mackey before it got famous. Is there anyone trying to connect? No. You just can't. Let's wait for 10 seconds. I'm going to count down from 10. 10, 7, 4. Alright, so those are the rules. You're going to see a question. It's going to be there just for 20 seconds. I'm going to speak a lot of nonsense during this quiz. You need to type the right answer. But actually, there isn't any right answer, so try to be honest. We don't have any prizes. So basically, you don't have any reason to actually attend this quiz. But let's do it anyway. Ready? Yeah. Ready? Yeah, get excited. I don't know why. Just get excited. All right. Ready. Let's do it. Do you know React? Hopefully. Look straight into the dog eyes and see your future. Try to be honest. We will use this data. And we will pass it to third-party countries. All right. This seems to be honest. Are you looking for a job?
Yep.
Like this person?
Yep.
What? Too loud? That's better? You can do like this. have any pizza left, so you've got plenty of time. Just would you try MobX? Do you know this person? Who knows who this person is? This is actually one of the greatest evangelists of MobX out there. Very known speaker of the community. How many vegans did we get today? How many hungry vegans? Right. Which teaching style you prefer? Help us a bit better. This question is actually quite interesting. Right. Handsome. That's nice. Do you like the new method.com design? Let's be honest. Actually,
Maybe A/B testing.
If you're blind, you'll not be able to answer this question. Just realize that. I haven't thought about it. That's interesting. What's blind? You got a little blind people right here. Do you even unit test? Do you unit test at all? Be honest. There are real developers test and surprising results. That's how you try later. Alright guys, just a few more questions. How big is the front end team in your company? Remember, this is completely anonymous. So if it's just you and your mother, that's totally fine. Raise your hand, come on. Yeah, I thought so. Alright, guys, meet up outside of Manhattan. I don't know. Who's never left Manhattan? Raise your hand. I really want to see this answer.
What about Jersey?
Alright. Yeah, we've got at least 8 people ready for camping. Which technology do you use on the server side? MobX. Are you a Java, C#? JavaScript all the way. Where's PHP? And there's no PHP. We are not promoting PHP on the internet, you should know. Right. So yeah, JavaScript full stack. Alright, which fruit is forbidden in Canada? Any Canadian in the audience today? Someone from Canada here? No? Alright. All of you just hitting the right answers, yeah? What it's gonna be? Yeah, that's the eggplant. If you know some other true facts about Canada, come speak with me later. Alright. What would you like to learn about in our future meetup? This is a serious question. We want to teach you stuff that you really want to know. And alright, that's interesting. Nice. Why do you come to ReactNYC? The last question. You've got an answer for this. feeling a lot of angry people, which is fine. This is community. We're here from you to help you heal from PHP, to feed you, to teach you stuff, and not if you're looking for a job. All right, thank you very much. Enjoy your break. We're gonna put a countdown on the screen, and see you later.
It's gonna be 13 minutes.
Exactly for you.
Exactly 13 minutes.
These
7:45
guys
we're
hiring.
here.
probably going to ask for like a mic check, so you can just like.
Alright.
Alright, everyone,
yeah.
pick up the
So we're gonna start about 3 seconds. So please invite everyone.
Turn on the mic?
Yeah, I did.
Oh, you did?
Yeah.
All right. So, applause to Jason.
Like the lady in the tramp style, or?
Alright, hi everybody. This is going to be a talk mainly on Scrollytelling. My name is Jason Kao, so let's get right into it. Yeah, sure.
It's on.
Okay.
Alright. Cool.
Test.
We good?
Alright,
cool. Hello. This talk is mainly going to be on Scrollytelling. My name is Jason Kao. So a little about me. I'm a freelance React developer right now working for a Canadian tech consultancy. And I'm an incoming freshman at Columbia. Tap Studios. Probably no one's ever heard of it, ever. TAPP. Yeah. So I'm an incoming freshman at Columbia, also studying CS and statistics. So what is Scrollytelling? Scrollytelling is a storytelling technique on the web where content unfolds as a user scrolls. Whenever I tell people what Scrollytelling is, I always love to show them Snowfall. So Snowfall is one of the New York Times' best Scrollytelling pieces. Basically, as the text scrolls, the graphic also transitions to match the text. Cards pop up also at some point, and it just supports the storytelling on this piece. So that's basically Scrollytelling. Why should you consider using it for your next storytelling interactive? To answer this question, I'm going to use Bran Feren's quote, "The web is a storytelling medium." So I really dig this quote because I'm from high school. Well, I just graduated high school, and all my friends, whenever I tell them I do web development, they're always like, oh, like I hate JS, I hate CSS. Why are there 3 equal signs everywhere? Like front end is so boring. But no, obviously I hope most of the people in this room don't think that way. I really do think that web development is beautiful, and web development can be very thoughtful. And interactive web development is not just flashy animations, obviously. On the web, we have several different types of content, like text, image, video, audio, other multimedia, and the web brings them together in a very unique medium. Scrolling is just an intuitive way to do that. So basics of Scrollytelling, the sticky graphic pattern. The sticky graphic pattern is one of the most popular ways to implement Scrollytelling. Basically, what happens is you're scrolling, a graphic comes up, it sticks for a duration of steps, and then when the steps conclude, the graphic scrolls back up. Sticky graphic. So, yeah. I think one of the best examples of this is from The Pudding. One of their most recent articles is about women in the House of Representatives. So what happens is there's an intro, you scroll down, graphic sticks. Apologies for it looking bad, I guess it's not responsive. In this article, we only focus on the House of Representatives, whatever. And as each step goes up, you see it triggers transitions in the graphic. Yeah, it brings you through a whole data analysis. It brings you through the story. So how do we actually implement Scrollytelling in React? I'm going to split this part into 2 sections. The first one is step triggers. The second one is sticky positioning. So in the olden days of like 2015,
what everyone would do is you would add an event listener or request an animation frame and use a loop through all of your elements, get a ton of get bounding client recs, and that's how you would get the information necessary for scroll triggers. But, I mean, this is JavaScript, so it all runs on the main thread, and if you have a ton of elements like in the pudding article I just showed, it's going to be slow, and users are going to be frustrated with either their browser or the computer or just your website. So what we have now is the intersection observer. Basically, it's an API that lets you, well, it's a JavaScript API, that lets you configure a callback whenever an element referred to as a target intersects the viewport or specified ancestor element, which people call the root. And there's no need to do anything on the main thread with intersection observer. So I obviously think that things should be done by example, so let's create an intersection observer. Yeah, this is all you need to do. The options, let's go through each of them. So the root, as I said before, is basically the viewport. It's to check the visibility of the target. So it defaults to the browser viewport, which is why we configured it as null. But you can put any of the target's ancestor elements as the root. So the target is the blue rectangle. Just imagine we're scrolling up. The target's coming up from the bottom into the viewport. And the threshold is the target's, like the percentage of its visibility in the root. So when we set it to 0.5, we're talking about if 50% of the target is inside the viewport, then the intersection observer will call or call back. Now the root margin basically just serves to grow or shrink the bounding box of the viewport before you compute intersections. So we had a negative margin of 20%. So that shrinks the box. So even though 50% of our threshold is already in the viewport, the intersection observer won't call the callback until it's in the yellow box. 50% of it is in the yellow box. So yeah, after you have those options, you add in a callback, you .observe a target element, and you're all good. You're all set. So next part, the second part, is sticky positioning. Sticky positioning is basically the love child of relative and fixed. What happens is when you're scrolling down, and sticky elements are static, they're relatively positioned, until you get to some threshold when they become fixed. And that threshold is any directional declaration, such as top 0. So if you put top 0 on a sticky element, then it'll be position fixed when you scroll, when you hit the top edge of its parent in the screen, or the viewport. So I don't want to take you guys through a thorough implementation of an actual Scrollytelling interface, because it's just a bunch of tedious intersection observers everywhere that are it's gonna take about an hour. I don't want to lead you guys through that. So I basically implemented a very simple one yesterday called React Scrollama, based on Russell Goldenberg's Scrollama JavaScript library. Ton of intersection observers. I'll just show you guys what it does. So we have the graphic on the right, and we have our steps on the left. And the trigger is at 0.33, which means I just configured a bunch of root margins to match it to that offset up on that viewport. So when the steps pass the trigger, I highlighted them, and I put their data into the state of into the state that controls, or not controls, it contains the graphic and the steps. So that's how the graphic gets the data. Graphic will become fixed at some point, and as the steps go through, it'll just work its magic. And then we scroll down, and it's on its way out because it's a sticky graphic. And that's pretty much it. I showed you 2 technologies that you can use for Scrollytelling, React Scrollama, and this is my contact info. My React Scrollama is also on my GitHub. That's my Twitter. You can be my 7th follower. So yeah, thank you.
I've always wondered, basically, who builds out articles like that? Because I imagine, I just trying to imagine who at New York Times gets together and produces that level of
Oh yeah.
Do you know?
Yeah.
Repeat the question.
So sorry, what's your name? Kurt asked, who at the New York Times actually has the time to build those huge articles. So what the New York Times does is they have two desks. So they have the interactives desk and the graphics desks. The interactives desk kind of builds the tech framework that reporters can use to build tech like this. And then the graphics editors, they actually build the graphics. They can spend weeks at a time. They're not on the same timeline as a regular reporter. But they are on a tight deadline, which is why it's kind of buggy. But it's a very good article anyways. So yeah.
Another question? Right then.
Thank you.
You got the mic from you?
I'm Tech, and I'm the CEO. And you probably also noticed that Nir made a joke about MobX in his quiz on my behalf. So for all of you who are recruiting, Nir is also looking for a job, starting now. He's a pretty decent developer. So yeah, it's a little short for me. So usually when I do a talk about MobX, I explain what it is and go into the internals. And then I speak about MobX versus Redux. So I decided to do the opposite. Because usually when I start talking about MobX, people think in their head, why do you need it? Like, we have Redux. So I just want to quote Dan Abramov, the creator of Redux. He tweeted awesome stuff about MobX in March 2016. And half a year later, he tweeted, you might not need Redux. So that's an interesting point. But to be serious, what he meant was a lot of people say, like, Redux is so much boilerplate. Like, you just want to change one property. Why do you need an action creator and an action and a reducer and a middleware and immutable data? And what people usually say is, yeah, but Redux gives you structure, and it's much harder to make mistakes when you use Redux because it gives you architecture. Well, in fact, that's not true. Like, you can build really crappy code base with Redux if you don't know what you're doing. And what Dan Abramov said is you should use Redux. Redux comes with a lot of boilerplate, but it also gives you so many things like serializing your data, loading it from local storage, time traveling, etc. And so you should know that all of these come with Redux, and if you want to use it, this is what you get from it. Okay, so this is Michel. He created MobX, and he says that people use it as an alternative to Redux, and you should know that it's just a library. It has no concept of a store. It has no concept of data flow. It has no concept of some kind of architecture paradigm. It's a library, and which means that when you use it, you have to think, which is not such a bad thing. You should find out. It could be a dangerous thing, but if you use it wisely, it will do very good for your code base. So we're going to get to the actual internals of MobX, but all of these advantages of Redux can be used in a library that is built upon MobX, and it is more opinionated, and it's called MobX State Tree. And it gives you everything that you can get from Redux, like serialization of the state, time traveling, and all of these cool things. So some facts about MobX. It's very popular, and a lot of companies use it. It has a lot of teaching material on the internet. It's used by a lot of large-scale applications and companies. And okay, so what is MobX, right? If you don't know, who knows what MobX is? Who uses it in production? All right. Who likes using it? Yeah, cool. So it's a tool for making objects reactive. It's really simple. Let's take a plain object. It's a class with an email property and a function to mutate the email. What does it mean, reactive? Reactive means that if the model changes, we want to do something. Let's say we want to update an input. So first we update the value of the input with the value of the model, and we change the model, and now we have to update the input again. And now we change the value of the model again, so we have to manually update the value of the input. This is not reactive, this is manual. How can we do it automatic with MobX? In MobX, you have a function called autorun. You basically just wrap the side effect, the reaction function, in an autorun callback, and then it will automatically run whenever it needs to be run again. It looks like magic. There's one thing that's missing, is that to tell MobX which properties it needs to observe. And we do it by decorating our regular object, no crazy immutable data things, reducers, middlewares. You just add a decorator called observable to the property. This is not observable from React.js. It's just the same name. It's a completely different thing. And then MobX knows, it actually wraps this property with a getter function and a setter function. So it knows exactly when you access that property. So that's what happens under the hood. So the first time you call autorun, MobX creates, this is like the internals of MobX. It creates an object called reaction. It gives it some name. And then it runs the callback function of the autorun. And now when you use an observable value, MobX knows about it because it replaces it with a getter and a setter function. So it says, okay, this reaction depends upon this observable. So it builds this dependency tree. And then every time you set a new value, let's say for the email property, MobX also knows about it, and it checks all the dependency trees, and then it knows, it looks for the reaction, and it knows to rerun the reaction. So basically, MobX is pretty much the only state management tool or reactive tool that automatically knows, like, has intimate knowledge of your app. It knows what depends on what, and it can update it very performantly. It also handles duplicate state. So let's say you have a validity flag on your class, on your model, which says if the email is valid or not. Basically, if you keep this as state, then you duplicate the state because you can infer the validity of the email from the actual value of the email. So we handle this in MobX in a way that's very similar to the autorun, to the reaction. We use something called computed from MobX. And it acts the same as the autorun, but it also caches the value. So the first time you call is valid, MobX will run this function. It will calculate the validity of the email, and then it will cache the value. Then every time you call this function, it will return the same value. So this makes the applications very performant out of the box. And whenever you change the email, it has the same dependency tree mechanism. It will recalculate the is valid. Async operations is very difficult things to achieve with Redux. And in MobX is pretty straightforward. You just do something async, and when it returns, you mutate the data. And when you mutate the data, MobX will operate synchronously. So there's nothing really special about this. This is ReactNYC, so what does it have to do with React? In React, you don't update values of inputs directly, right? You render components. And usually when you have a large application, you don't have all of the state inside your components. You have some kind of state management, some kind of store that holds state that needs to be shared between components. So these components need to re-render whenever this state changes. So let's take imaginary component. It uses some values or computed values from the model. In order to make this component reactive, to react automatically to changes in the model, all you need to do is add the observer decorator. And that's it. How it works internally, you can go into MobX source code. It's not that complicated. Basically, it like re-implements the render function, and then it can automatically know which observables you used inside the render function, and it forces the re-render whenever they change. So it's very straightforward. It's very simple. This is all you need to know about like basic of MobX. The API is super slim. And once you get to know like how it works internally, then the magic also like disappears and you can debug it better. So this is like a very simple example. And a lot of times, you know, to do apps, they look really simple, but when it gets to a large application, then you have different kind of challenges. So what I want to show you is an app. It's also a demo app, but I can demonstrate a few more complicated things with it. So it's some kind of shopping cart. I'm missing an image. So you can buy things whenever I click. This component also, the shopping cart loads. I can also toggle it from here. So I can change the quantity from here and also from here. I can remove items. And I get like computed values, which are the total of each item and the total of the entire cart. So you can already see why you need like state management even in this small application, because a lot of components share the same data. I can also filter. So how do I go about in constructing this with MobX? So the first thing I'm going to show you is what stores I have here. So the first store is just raw data of the products. And one thing to notice here, so there's just one observable property here called items. One thing to notice is that it's not an array, it's a dictionary keyed by the ID, which makes it easy to look for a specific product by ID. That's also a common practice in Redux. And the next store is the cart store, which is this one. It also has items, and these items will actually say what I have in my cart, but they need to somehow refer to the product store, because I don't want to save the same data inside the cart. So the first thing to notice here is that I'm using a map. Who knows what JavaScript map is? So it's basically a dictionary, and it makes it easier for MobX to track objects with dynamic keys. Okay, so in this, let's say cart, it only has the items property. It's not dynamic. But the items property has, it will be keyed by the ID of the item to also be like a normalized state. So when you use the map, you use set, a method, and get and delete. It makes it easier for MobX to track it. That's the first thing to notice. And the second thing is that each item inside this map, let's say in the add item method, I wrap the object with another class, which is called cart item, which is here. So it's very object-oriented. Everything is encapsulated. And every cart item holds a quantity, like how many of this item and which product. Now, because it's object-oriented, a lot of people have a tendency to keep an actual reference to the product from the product store. The problem is with this is that sometimes you refresh the data from the server, and then all of your references will be broken. So what I recommend to do is only keep the ID product. And then when I want to get the actual product for its price, its image, its title, it's actually a computed property, which uses the product store and tells it, okay, give me the product with this ID. And because it's a computed property, it will only recalculate whenever it actually changes, which is very good. Okay, so we have some kind of store hierarchy. Okay, this is one of the first things people say. Like in Redux, you have just one store. In MobX, if you have a lot of stores, it will be a mess. So you just do the same thing you do in Redux. You have separate stores. You normalize and flatten the state. And you have computed values, which if you do advanced Redux, or actually basic Redux, you have selectors, which can select from different stores. So it's pretty much, or different reducers, it's pretty much the same thing. So you need to keep some kind of hierarchy of stores. So I would say that the product store is more low level. It's just raw data. It has no dependencies. And the cart store, it knows about the product store. One more thing that I did here was to do automatic persisting to local storage. So if I have like 2 items in my cart, if I refresh, I still have 2 items in my cart. And it's all persisted automatically to local storage. This is also very easy to accomplish. So in my constructor, I just run inside an auto-run function. I just save the items to local storage. I'm using a utility from MobX called 2JS, which takes the objects and just serializes them to plain JavaScript. And that's it. Because it's inside an auto-run, it will persist this cart to local storage every time you do any sort of change. Now, that could be not performant, because every time you do some change, it will save to local storage. So MobX comes out of the box with a few cool things, like debouncing. So let's say I do 2 seconds debounce, which means I can do a lot of changes, and only after 2 seconds it will be saved in local storage. And you can also name your reactions to get good debugging. Speaking about debugging, Chrome extension, I can see all of my components, and I can actually explore. I don't know if you see it, it's too small. I can actually explore the dependencies of these components. So I can know, okay, this component, what if I change something, what will it affect? So I can see, okay, this component, which is the shopping bag, it relies on the cart.count, which is a computed value. And I can also go inside and see that this depends on the items array of the cart. So you can really go into the internals of your application. You also have the changes log. So let's say I add a new item. I can see I have the add item action and the open cart action. And I can also see which components did the re-render. And also this reaction, which is the persist to local storage, I gave it a name. That's why I see it here in the debug window. So also it's really easy to get a glimpse of what's going on inside your app. And I think the last thing I want to show you is you have a method from MobX called trace, which tells you basically why this reaction run. Like sometimes you have these reactions that run and you didn't plan for them to run and you want to know why. So whenever I call trace, it tells me persist is invalidated due to a change in cart item 5.quantity. So it tells me, okay, this is why I reran this reaction. So you can actually do very good debugging. Okay, time for some shameless promotion. Now that you're all tired, How do I exit full screen mode? Okay. So as I mentioned, I'm from 500 Tech, and I don't have internet. I had a hotspot. This is because of your quiz. So I will tell you about 500 Tech without showing you our amazing website, which we are currently rebuilding with Gatsby. And oh, there it is, hummus. That's the name of my hotspot. So we do web development, consulting, and training. Basically, we help companies ramp up their technology stack. It can be performance, optimizations, migrating from an older technology to, let's say, React. Ramp up your build process with Webpack, etc. And we also do trainings, so like full-on courses. You can go to 500tech.com, check out, hopefully my hotspot will work. Check out some cool projects that we built. These are some of our clients. These are us. We also run meetups and like this one and conferences. Write books, open source, do all sorts of fun stuff that don't give us any money. And that's it. So I invite you to go to the website and say, hi, Adam. Great talk. And your email, and send.
Because I got fired.
Yes.
Do you hire?
Yes, we just have an opening now. And yeah, are we hiring? We're not hiring. We're hiring? Yeah, we're all in Israel. We're always open to good people with good vibes and good skills. 2 questions?
2 questions.
Yes.
Why don't you use WebStorm?
The question is, why don't I use WebStorm? Well, actually, I switch a lot between projects, and it's just super fast with VS Code. And with WebStorm, it takes some time, and I'm a freak of productivity. I also know all the shortcuts of Gmail by heart. So you see me just typing, I'm on Gmail, and that's it. Yeah, WebStorm is great. I have nothing better to say.
That was the question from you.
Oh, okay. Oh, yeah, I was like, why are you asking about WebStorm? You're fired again, yes.
Redux to MobX, it seems like it's doing a lot of wrapping of render and auto run does its stuff. When you compare like a Redux to a MobX, what's the startup time, what's the performance hit?
So the question was, what's the startup time and performance of MobX, because it does a lot of like wrapping and dependencies. So it's really hard to compare, because in some use cases MobX is like much faster, and some use cases Redux is faster. Both of them are extremely fast, and it does things in a very performant manner. In MobX 5 they're using proxies, so they're doing a really good job. It's already version 5, so it's good. Another question, because yeah, the first question was trolling. Yes.
I just have a question. So from AngularJS, we kind of learned that like two-way data binding just leads to a lot of like implicit dependencies between components, and it's just kind of you can get into a really hairy spot really quickly. Could you elaborate a little bit more on like that's a very sharp edge and a very tough place to get into. Can you elaborate a little more about how MobX solves that issue? Because it seems like it's relatively similar, where you have, yes, you declare that things are observable and an observer, but you're still mutating state and having objects react to mutations.
So the question was, in Angular, you have two-way binding, which creates a lot of mess. And how does MobX solve this, or does MobX use two-way binding? So basically, MobX has nothing to do with two-way binding. And so I said that MobX doesn't come with a data flow, but you should still think in a Flux way that if you update, if you take a value from an input, you call an action, and that's it. You forget about it. And then when you use the value, you take it from the state. So you don't need and you shouldn't do two-way binding when you're using MobX, and you should adopt this Flux way of thinking of this. As a component, I get data from the state, from the store, present it, and then I take an event from the user, call an action, and that's it. Like the only difference is that calling an action is just calling a function, not firing an action, dispatching an action, and using a value is just using the value and not doing selectors and stuff like that.
And you should probably use MobX stage tree anyways.
You should think what you want to use.
All right, thank you so much. So I think we have time to hang out until 9-ish, but by 9 we have to leave the building. So Adam would be here, all the other speakers would be here. That's better. Yeah, thanks Sarah for coming. Thanks so much to Wood for his book and for sponsoring the meetup. Thanks so much for Discovery, for great space and all the pizzas and drinks. Thanks for coming. See you